Okay guys, today let's talk about Friedel-Crafts Alkylation with a K. Generally, this is going to be your best bet to add 2 carbons or less to a benzene ring. 3 carbons or more, and you want to use acylation. And the reason is this step right here and kind of our pre-steps here, this is going to function as a leaving group, and when it does, it's going to create this carbocation here. This particular example, even though I did use 3 carbons, I generated a very stable secondary carbocation right off the bat. I'm not really concerned about any kind of rearrangement that can occur. However, if I had had something like this, and then this thing branches off, I'm going to have a primary carbocation. So I will have a mixture of products between a 3-carbon propyl group that looks like this, as well as this isopropyl group, which comes from the hydride shift that creates more secondary carbocation in this case. So rule of thumb, 3 carbons or more, use Friedel-Crafts acylation with a C. 2 carbons or less, use Friedel-Crafts alkylation with a K. So now your first step, kind of a pre-step, this guy leaves and generates this carbocation here. This molecule is not going to undergo any kind of rearrangement. So here's my electrophile. The pi bond is going to reach out, form a bond to that carbon there. So these 2 electrons, which did make up this pi bond, are now tied up in this sigma bond. As a result, this carbon is now missing a bond, so that's where your carbocation is. Benzene resonance inside these brackets, aka sigma complex. This pi bond is going to reach over here to stabilize that carbocation. Now it's going to render this guy without a 4th bond. This guy's going to come to the rescue. So now carbocation is here. And then remember when we kicked this guy off earlier, we've got an AlCl4. It is going to come down like this. And it is going to grab that proton. The 2 electrons which make up that C to H bond are going to kind of collapse towards that carbocation, and it's going to ultimately restore aromaticity, aka that 3rd pi bond in the ring, giving us our 3-carbon group in the form of an isopropyl group added to our benzene ring. If you found this video helpful, check out others like it. orgogoat.com. Lots of practice problems there. More in-depth explanation for this concept as well as some others. Please like, comment, subscribe to all of our videos and our YouTube channel to help reach more students like you. Tell all your friends you've got a fantastic tutor. And if you're interested in private tutoring or if you want a concept explained that you don't see on our YouTube page, hit me up, orgogoat, yahoo.com.